Okay, so now that you're pretty good at mirrors, curved mirrors, it's time to look at lenses. So this, I believe, is number 2, and it's images formed by refraction. Now, at the end of grade 11 physics, in theory at least, you learned about refraction. Refraction is the bending of a wave as it passes from one medium to another. And if you were in my grade 11 physics class, we talked about imagining we were in Hawaii. And if we were in Hawaii, of course, we'd be walking along the beach, well, assuming there's no COVID there. And we'd be walking hand in hand just because we'd be excited to be there. So we would form like a straight line. This is us walking in a straight line. And this is where the ocean is meeting the sand, okay? And so we're walking this way. This line could almost be considered our wave front. It's like our front that's going to move forward. So as we walk, these are going to be parallel. But the poor people on the edge, this edge, the water edge, they're going to end up in the water as we walk. And when they end up in the water, it's not as easy for them to keep up. And so we go this way, but they begin to go that way. And so originally then, our wave is traveling like this. But as we go along, our wave fronts get bent in their direction. And if we were to keep going, they would end up, so the direction we're going in is always perpendicular to the wave fronts. So they would end up getting bent and traveling like this instead of straight through. And so refraction is the bending of a wave as it travels from one medium to another. So just like our wave front gets bent here as we walk along, light would get bent as well. Probably what you would remember playing with as a kid would be like a glass of water, and you put a pencil or something in it. And you would see the pencil coming down, and you can try this at home. But then it bends to the side here. Okay, it was always great, maybe not quite that dramatic. It's also why, if you've ever been in a store or at a carnival where they have this like thing of water and they have a little, I don't know, like container down at the bottom, and if you can drop the coin in the container, you win money. But the problem is, because of refraction, you see the container here, but it really isn't here. So you try to drop the coin straight down, but it ends up off to one side or another. Okay? So refraction is the bending of a light ray as it goes, or any wave, as it goes from one medium to another. As it goes from less dense to more dense, like air into water, or for us in this unit, air into a lens, which will be glass or plastic. Obviously, the light is going to slow down because it travels fastest in air, fastest in a vacuum, really. Next fastest in air, and then slower in water and plastic and glass, etc. You can imagine a light ray being like you running down the hall. You would travel at your fastest speed if the hall was empty, which is what is true for a vacuum and pretty much true for air. There's very few molecules. There's more molecules in water, so the light has to slow down to get through. More again in plastic or in our lens and glass, so it has to slow down more. So it's the effect of the slowing down, just like these guys in the water, that causes the bending of the light ray. Okay? When you go from less dense to more dense medium material, it's going to bend towards the normal. And I'll explain that in a minute. But hopefully some of you remember this. And when you're going from more dense to less dense material, it bends away from the normal. And in grade 11 physics, I always think of MLA, member of the Legislative Assembly if you're into politics, or a type of formatting in an essay. Okay, more to less away. So then the other one is less to more towards. What do I mean by that? If this is my surface and a light ray comes in and strikes it, always we measure the angle of incidence, the incoming angle, with a line perpendicular to the surface called the normal, just like we did for reflection. So this is my angle of incidence. So if it's going from less dense to more dense, like from air into glass, if it didn't bend at all, it would just follow a straight line through. But going from less to more, it's going to bend towards, which means instead of going like this, it's going to bend down here so that it's closer to the normal. If it's going from more to less, it's going to bend away, which means it's going to bend up here. Okay? And there is an angle for those of you that did the work in Physics 11, either first semester or second semester when we were home. The equation, which we won't be using in this course, but which I'll remind you of, it was called Snell's law. And the ends told us about the density of the material, and so the bigger one density, the smaller the angle would be, so that these would end up equaling each other. Okay? So it was known as Snell's law. What do you need to be able to do this? You need to know that light's going to bend as it goes from air into the lens and then back into air again. It's going to bend one way and then it's going to bend the other as it goes less to more and then more to less. Okay? All right, so back to lenses, which are what we're going to use for images formed by refraction. Okay, so what is a lens? In plural, a singular for lens is L-E-N-S. Plural is L-E-N-S-E-S. So a single lens doesn't have an E on it. And what is a lens? It's simply a disc of transparent material like glass or plastic that has curved surfaces. And when light passes through the lens, the light rays are refracted to form an image. So a disc of transparent material such as glass or plastic, and nowadays a lot of other high-tech stuff that we've made for our glasses and for our contacts. So a transparent disc of material made of something like glass or plastic with curved surfaces. And when light passes through a lens, light rays pass through a lens, they are refracted to form an image. Now there are two different types of lenses, concave and convex. Aren't you excited? Okay, so one that looks like this and one that looks like this. The one that caves in is called a concave lens, just like the mirror that caved in. And the one that bulges out, it's called a convex lens. Now, hopefully, you have the mirror stuff straight in your head, because that's really going to help you here. If you don't have it straight in your head, I could really screw you up here. Okay, the good news, there's still going to be a principal axis through these guys. Okay, actually, we're going to start with converging lenses. Remember, in mirrors, the concave mirror was the converging lens, and the convex mirror, was the converging mirror, and the convex mirror was the diverging. Okay, so we're actually, so A this time is going to be convex lens. And so if I draw my convex lens, nice and pretty, and I draw my principal axis through it, there is still a point, but this time it's going to be on both sides. And I know when I was first learning lenses, I always thought of them as like two mirrors that were back to back, right? And so like one will have an F and a radius of curvature on this side, and one will have an F and a radius of curvature on the other side. So lenses have an F on either side. It's kind of like if you take your glasses off, and if you have glasses, and turn them around, assuming they're not progressive lenses, which they probably aren't at your age. If you take them around and look at them backwards, right? Instead of looking at them this way, if you turn them this way and have them in the